In this video, we're going to talk about total probability. Total probability. So suppose that A and B are two events. Then B equals B intersection A union of B intersection A complement. Yeah, we've sort of touched on this before. If you remember, we had that little diagram. Say we have maybe A over here and A complement, and then B intersection A over here, and then B intersection A complement over here. And notice, of course, A and A complement are always mutually exclusive. Anytime you have a complement of something, it's always they're always mutually exclusive. And then therefore, of course, you can see for this diagram here, this is our set B. And so since A and A complement are mutually exclusive, then B intersection A complement and B intersection A and B intersection A complement are also mutually exclusive. And so now we can kind of work with this and say, again, you can get all of B by putting the union of these two. And so now if we do the probability of B intersection A union B intersection A complement is going to be equal to the probability of B intersection A plus the probability of B intersection A complement. And you remember, we can do this step if and only if these two sets are independent or are mutually exclusive. In other words, that the intersection of this and this is the empty set. And that's what it means to be mutually exclusive. That's another definition for if we intersect this and this, we get the empty set. And if that's true, then we can reduce this when we're calculating it to probability of this plus the probability of this. Again, because they're mutually exclusive. And then we can take one more step. Remember, in a previous video, we said we could write this as probability of B given A times probability of A plus probability of B given A complement times the probability of A complement. Now we can extend this to several sets. So suppose you have like A1, A2, A3, maybe let's stop at A4 are several events that are mutually exclusive and exhaustive. Again, exhaustive would mean that these cover all possible events. In other words, you will have to get one of these events. There's nothing missing here. So that if you broke, say, if you broke your set down, and let's say if you had A1, A2, A3, A4, like this, again, you would have all the events covered. And then once again, let's suppose you have another set. Again, we can call it B. And let's say over here you have A1 intersection B, A2 intersection B, A3 intersection B, A4 intersection B, like this. Again, so this is the whole thing is a set B. And now again, keep these things in mind. These have to be mutually exclusive and exhaustive. And then in that case, since these are exhaustive and mutually exclusive, the sum of the probability of the AIs from I equal 1, in this case we have 4, but it could be up to however many you had, is going to be 1. And again, as we said before, if you have like AI intersection AJ, where I is not equal to J, this is going to be the empty set because they're mutually exclusive. And another way to say it's exhaustive would be to say if you took the union of all of these, you would get the sample space. And now the total probability rule said this. The probability, and this is similar we just did a minute ago with two sets. The probability, again, because these are mutually exclusive, remember we can say that these probabilities can be broken down into sums. And again, I use 4 here, but you could keep going on with as many as you need. And let's say assume we have more than 4. Let's say up to B intersection, maybe let me say it this way. Plus probably of maybe go up to AK intersection B. Again, this is equal to probably of B given A1 times probability of A1 plus the probability of B given A2 times probability of A2 plus probability of B given A3 times probability of A3. And it could go on up to your last one, probably B given a K times the probability of AK. And this is sometimes called the total probability rule. And let's do an example. Suppose that we have the following information about light bulbs made by a company. %62% of the light bulbs from, say, the Minnesota plant last more than 7,000 hours. And let's say 67% of the light bulbs from the Illinois plant same thing lasts more than 7,000 hours. 57% of the bulbs made in the Colorado plant last more than 7,000 hours. So we have this information. We also know 20% of all bulbs are made in Minnesota plant. 45% of all bulbs made in the Illinois plant. And 35% of all bulbs are made in the Colorado plant. So what percentage of the bulbs last more than 7,000 hours? What percentage lasts less than 7,000 hours? So let's take a look at this. Now again, notice we have here's all the bulbs being made. Now, this event here, if you want to call it where the bulbs are made, these are all mutually exclusive and exhaustive. In other words, if you add these together, you get 100% of the bulbs. And if a bulb is made in Minnesota, it's not made in Illinois or Colorado. If it's made in Illinois, it's not made in Minnesota or Colorado, etc. So that's that. You can think of that as maybe like the main sample space. So we can actually make a little picture like this. Again, I'm going to make the line straight this time. Again, we have Minnesota, all that MN, Illinois, L, Colorado, CO. And let's call the event SV is the event the bulbs last more than 7,000 hours. And so let's look at that. And so again, let's call this our set SV. Again, I just call this S sub V. You really call it whatever you like. SV is the event that the bulbs last more than 7,000 hours. And so over here we have Minnesota intersected with SV, Illinois intersected with SV, and Colorado intersected with SV. So now we want to know what the probability is of the bulbs lasting more than 7,000 hours. That was the first question. What is the probability or the percentage? And we usually work with probabilities. So let's actually maybe start writing some things up, and I might need to do this on another page here think of what we're given. We're given these percentages of the bulbs lasting. And so what this is really saying, so this one here says 62% of the bulbs from Minnesota last more than 77,000 hours. What that's really saying is that given that the bulb is from Minnesota, the probability that it'll last more than 7,000 hours is going to be 0.62. So let's write that down. The probability, given that the bulb is from Minnesota, the probability of lasting more than 7,000 hours is 0.62. And we go to the next one, 67% of the bulbs from Illinois last 7,000 hours. So that's saying probability Illinois, the bulb is from, given the bulb is from Illinois, that it's going to last 7,000 hours is going to be 0.67. And finally, if it's from Colorado, the probability it's going to last 7,000 hours is 0.57. So, I don't know if we're going to need it here yet, but let's also write down the complement of these. So if we know that 62% of the bulbs from Minnesota are going to last 7,000 hours, then we know that the complement of not lasting 7,000, excuse me, the complement of that is not lasting 72 hours, 7,000 hours, excuse me, I'm getting all messed up, is going to be 1 minus this, or 0.38. In other words, 62% of the bulbs from Minnesota last 7,000 hours. That means 38 won't make it to 7,000 hours. Again, we're doing this by complement. So again, also, if 67% of the bulbs from Illinois last 7,000 hours, then 1 minus 0.67, which is 0.33, for 33% will not last 7,000 hours. Finally, given they're from Colorado, the probability they're not going to last 7,000 hours is going to be 1 minus this, which is 0.43. Now, we also know the percentage that are from each of the states. Let's write that down as well. Probability if you pick a bulb at random, it's going to be from Minnesota. Is 20% of those are 0.2. From Illinois, 0.45. The probability from Colorado is 0.35. So we're going to use this information. And so now if we want this here, we want to know what the probability of SV is. So it's going to be the union of this with this and with this. And again, since remember this event, and this event are all mutually exclusive. So we can just use the addition of those. Probability that a bulb is going to last 7,000 hours is going to be probability of SV intersect Minnesota plus probability of, messed that up, didn't I? Let me fix that, sorry. Probability of SV is going to be probability of SV intersect Minnesota plus the probability of SV intersect Illinois cross probability of SV intersect Colorado. Again, I'm just taking probably the union of these, since they're mutually exclusive, I can change that to sums. And once again, just like we did a few minutes ago, we can rewrite this as probability of SV given Mn times probability of Mn. Now, one thing to note here is, remember, if you go back to the probability of the intersection, we can write that as Mn given SV times probability of SV, or we can write it this way: SV given Mn times the probability of Mn. Now, the reason we chose to do it this way rather than probability of Mn given SV is because we know this information up here. So we want to rewrite this in a way using information that we know. Same thing over here with this next one. We can write this as probability of Illinois given SV times probability of SV, but we don't know probability of Illinois given SV, but we know probability of SV given Illinois, so we'll write that form: SV given Illinois times the probability of Illinois plus, same thing with this one here, we want to use the one we have here, probability of SV given Colorado times the probability of Colorado, like that. Now we know all this stuff. We can put 0.62, 0.2, 0.67, 0.45, 0.57, 0.35. And put that in your calculator. So the probability of a bulb, this is a bulb just in general lasting 7,000 hours, is 0.625. Or if we want to turn that into percentage, or 62.5% of the bulbs will last more than 7,000. The same thing with probability. Actually, the second question asks, what is the probability, or excuse me, what is the percentage that'll last less than 7,000 hours? Now, of course, what we could do is just take 1 minus 0.625, and that would give us the 0.375 or 37.5%. But let's actually go through, let's suppose we didn't know this part here. And so we have probability of SV complement, which is probability of it not lasting 7,000 hours, is going to be probability SV complement intersection Mn plus probability of SV complement intersection IL plus probability of SV complement intersect Colorado. And this is going to be probability. Once again, we could put this as MN given SVC, but what we know is SVC given MN, so we'll write it that way. And same thing over here. Probability of SVC given IL. Probability IL. Probability of SVC given Colorado. Probability of Colorado. And so if we plug our information in, we have 0.38 times 0.2 plus 0.33, 0.45 plus 0.43, 0.35. And if you calculate this, this is 0.375 is a probability that a bulb won't last 7,000 hours, or we can say 37.5% of the bulbs will last 7,000 hours or less.